Hello everyone. Let's talk about LeetCode 301. It's on remove invalid parentheses, and it can be solved by multiple solutions. For example, we can use BFS and we can use DFS. It's also a very good question that appear in a lot of interviews, for example, in Facebook. Okay, let's take a look on how to solve it. So the description is very simple. Remove the minimum number of invalid parentheses in order to make the input string valid, and we need to return all possible results. Note the input string may contain letters other than the parentheses. For example, here it says A here. So in the first example, we can remove the closing bracket here, right? And it says also another valid string, so there are two answers here. And for the second example, there are also two answers here. For the third one, we need to remove all of them. Okay, so it sounds like a very difficult problem since there's no trivial way for us to get the correct answer here. So we need to do some search algorithm. The core problem here, how many parentheses should we remove? We know we should not remove letters since it's useless to remove letters. So we should remove parentheses. So how many shall we remove? For example, in example 1, we remove 1. Example 2, we remove 1. In example 3, we remove 2. Okay, so we need a function to know how many shall we remove so that we can make the output a valid string. Okay, here we use stack, and we have valid number. So the arrows is the total length minus valid number. Then we just iterate every character in this string. There's 3 cases: open bracket, closing bracket, and other letters. If it's all letters, we know we don't need to remove them. They're all valid. We just valid auto increment. If it's an open bracket, we just push it to the stack. Otherwise, if it's a closing bracket, we can pop the open bracket. Then we just add 2 to the valid number, since we consume the open and the closing bracket. So this is valid number. Then we just return total length minus valid number. This is how many parentheses we should remove. Okay, so the first idea is BFS. It's like the shortest path. For example, if we have an input whose error is 5, then we can try to remove every character like in this input. And we can pick the new string who has a smaller error count, right? Since there's intuition, when we remove an open bracket or right bracket from the input string, we increase errors by 1 or decrease errors by 1. Of course, we need to choose those strings who have smaller errors, right? For example, if the error is 5, which means we can remove 5 characters to get the valid output. Okay, let's implement it with BFS first. So this is the result, and finally we just return the result. And we just have 2 very classical data structures for BFS. One is queue, one is a visited data structure. First, we get the errors of the original string. And as long as the queue is not empty and the error is greater than 0, we continue our while loop. So here I use the level traversal here. So at first, all the elements, for example, my initial input has error count 5. So at first, all the elements in my queue has error 5. Next round, all the elements in my queue have error 4. Then next round, all elements have error 3, and so on. So at last, all the elements in my queue will have error 0, which will break the while loop. As long as it breaks the while loop, I just push all the elements in the queue to my vector. then I just return my vector. Okay, for level traversal, first I collect all the size of my count queue, and I just for loop so many times. In each iteration, I pop the element from the queue, and we have a pointer here since I need try to remove every character from my current string. Okay, so here I try every position, but keeping in mind we only want to delete left bracket and right. That's the open bracket and closing bracket since it's meaningless to delete ABC. Okay, then for each I, if it's parentheses, I just try to remove it and construct a new string called temp here. As long as temp is a new string, it has not been visited before, we try to process it. So we get the arrows from this temp. Since we only want to move to the a better direction, so as long as the arrow is smaller than arrows, we try to push it. And here we have some optimizations. Assuming this is input, we have 3 open brackets here. So it seems to delete any of them. So at first I is 0, we try to remove the first open bracket. Then we can just skip the next 2 brackets. So I++, here we run it twice. And here I++, so I will become 3 next time. It's a little optimizations. Okay, that's it. The BFS solution. Okay, next, let's try to use DFS. Why can we use DFS for this problem? We know that like how many parentheses we should remove. So we also know the final valid length, right? And we have the input. It's like for DFS, like we just iterate each position, and for that position, we can pick that character in that position, or we don't need to pick them. So this is the basic idea of DFS. We just try every possible combinations for a position. We use that character, or we don't use it. And finally, we can move all the valid strings into our answer. Okay, let's take a look at the implementation. First, we get the final valid length. And we have 2 data structures. One is visited, one is result set. Result set is my final result, and we just, at last, we move the result set to our vector and return this vector. Okay, this is DFS function. This is the original string. This is the index in the string. This is final valid length. And the count is the string we are building. At first, it's empty string. And left count is how many open brackets in my current string. Right count is how many closing brackets in my current string. And this is visited, this is result set. Okay, so if the string I'm building is the length is same as the valid length, then we know it's a corner case. If left count is same as right count, we just insert it into our result set. Then we can just return. Another common case is if indexes are of range, then we can just return. Okay, next, and here's a little bit of optimization. Assuming my string, my input starts with 2 open brackets. For example, we have a branch that we pick the first open bracket, then we skip the second open bracket. So when we're at the first X, we only have 1 open bracket. There is also a branch that skips the first open bracket, but picks the second open bracket. So when it's at X, it also has 1 open bracket. So the current are same. Then we have 2 branches that say are at the same state. So we don't need to run this additional branch since they're same. So we use the index and the current string to build the key. As long as it has been processed before, we return. We don't need to process it again. Otherwise, we mark it as processed. Okay, so in general, there are two situations. If it's a parenthesis or if it's normal characters or normal letters. Okay, this branch is very simple. If it's a normal letters, we know we don't need to delete letters since it's useless to delete letters. For a valid string, the final answer should always include this letter. So we just include it and add one to our index. So it's very simple. Okay, let's take a look at this hidden box. If it's a parenthesis, we have three choices. Actually, we have two choices. Like we can pick it, or we don't need to pick it. So this branch is that we don't pick it. We just increase the index, but the other state like hasn't changed. Let's take a look at this if. We thought this if statement, it also works, but the speed is a little bit slow. The performance is not very good. Let's take a look at what it's doing. Assuming the S length is 8, I is 6, count length is 4, val length is 6. So here, if we pick all remaining characters, we know the final current length is 4 plus 2. 2 is 8 minus I, right? 2. So the length is 6, which is same as valid length, which means like if we pick all remaining characters, then the length can be same as valid length. If we skip any character, then the length is smaller than valid length, then it cannot be a valid answer, right? So we have to pick the characters, right? So as long as that we don't have enough characters, we cannot skip it. So this is for our optimization. In this case, count length plus s dot size minus index is 6, which is same as valid length. So we cannot run this DFS. Since if we skip it, the length of my the current string will be smaller than valid length. So it's a dead branch. Okay. Now, if it's an open bracket, we can choose to pick it, right? But it's also for for performance. For example, left count, it's like too much. Valid length is 10, but the left count has already been 5, so it's useless to pick additional open bracket, right? Since you already have 5, but valid length is 10, if you pick one more open bracket, your open bracket will be 6. So your current string will be an invalid result. If it's a closing bracket, when can we add a closing bracket? So we can add an open closing bracket as long as in my current string, my open bracket is more than my closing bracket, right? Yeah, so this is the solution. It also runs very fast, like beat more than 90% of the solutions. So there, at first, when I wrote solution, I don't have so many if here. At first, the speed is not very fast, so I tried some methodology like to cut in some branches and get this solution. Okay, that's it. Thanks for watching. See you next time.